Yes, we are live. Well, yes, we are live, guys. Just give me one moment. Well, yes, we are live, guys. Just give me one moment. Well, yes, we are live, guys. Just give me one moment. So, yes, hello everyone. Welcome to the next episode of uh, effects of magnetic effects of current. So before we go further, I want to tell you guys one thing. Okay, one very important thing. I know. How do you like the new look? By the way, good evening, Siddheshwar. How do you like the new look? I just finally got a haircut, man. All right. So before we go further, I want you guys to remember one thing: stay at home and stay safe. I know it's tough for everyone right now, but as you see, there's a pandemic going on right now. The second wave is about to hit the entire world. Already US and Europe are going through this, so I want you guys to stay at home and stay safe. Okay, don't start roaming around. Be like this guy here. If you see someone coming close to you, just swim your way out. Okay, so stay at home, stay safe, sit safely, and crack IIT-JEE with India's largest online platform, which is Unacademy. Yes, so crack it with get the plus subscription using the code NSS1. It's pretty cool. You get extra offer also using this code NSS1, so you can go for it. I mean, it's pretty awesome. All right. Hello, guys. Before we go further, I want to like to talk a little about myself. I'm N Srikant. I did my BTech from IIT Kharagpur with an AIR of 385. I've been guiding you guys for the last 5 years. You guys only call me human calculator, not like I used to be called that before also. So you guys call me human calculator. I'm a Sunrisers fan. It was good while it lasted, and I'm DC fan. And DC is equally marvelous, if not better. So I'm a DC fan. Anything you'd like to talk or comment, put it in the comment section below. This is Let's Crack JEE in English channel. This is for those guys who have trouble understanding Hindi. Matlab, this is an exclusive channel in English for you guys, most of them from South India, who have trouble understanding Hindi. Okay, so everything here is going to be taught in English. So awesome session ahead, and this is how the learning Unacademy app will look. It has nice two semicircles. No. Operation busy ఉన్నాను గంటలు చేస్తాను. So this is how the app will look. Definitely install this. And one more awesome thing up ahead, guys. The Unacademy Combat. It's like the online fortnightly competition. It's a It's a quiz competition. It's like kind of like a JEE quiz competition. It's like a JEE global quiz competition. Like we have quiz shows in on individual platform, right? You have one teacher giving quizzes, another teacher giving quizzes, but this is India's largest fortnightly competition for IIT-JEE. Here everyone in the Unacademy platform will be here and will be giving this quiz. So the best questions will be given by the best educators you can find in the Unacademy. The best of Unacademy is going to be there quizzing you guys. So definitely take part in the Unacademy combat. The schedule for this contest for the second round. This is actually the first round was done on 7th November, 8th November, November 8th, and this is the second round. It's a fortnightly quiz show. The second round is here again. So definitely stay tuned in and attend this Unacademy combat. For class 11th, it is you have different topics. For class 12, you will have different topics. Class 13, you will have different topics. The details about these topics will be given to you in this will be coming shortly in this channel only. Stay tuned to this channel for knowing more about when the quiz shows will happen. All right. So this is magnetic effects of current part 6. So we have done with current carrying wires के कारण magnetic field होता है. That thing we already realized. All right. Just give me one page. एक पेज बोला तो एक स्लाइड दे दी है, पूरा स्लाइड शो दे दी है. So one thing we already know, magnetic effects of current, right? We already know the magnetic effects of current. So मतलब we all know current carrying wire will produce magnetic field. Okay, so today we will be discussing about how this magnetic field will be affecting charges and current. Current eventually आ जाएगा, but आज के लिए we will start off with how current will. Now one thing you know, current is a moving charge. No, one thing we know, current will be a moving charge. So इससे हम मतलब you can understand better. Current is a moving charge. Now one thing we know, a moving charge. Current is moving charge and neutral also. It's also neutral. So one thing we know, moving charges will produce magnetic fields. वो सब हमें we already realized that. All right. So today we'll be discussing how this field will affect, how magnetic field will affect a moving charge. How magnetic field, जो already हम पढ़ चुके हैं. We understood how magnetic field is formed due to wire, due to different kinds of wires. We already know magnetic field is produced. We discussed about intensity of magnetic field, कैसे produce होगा, कितना produce होगा. How magnet. Now we will see how this magnetic field affects moving charges. So one thing this was theoretically observed was that magnetic field does not impact charges at rest. Okay, this was experimentally observed. It only impacts moving charges. तो ये कितना कैसा होगा, what is the value of it, all of those we will be discussing in today's topic. The force on a charged particle due to a magnetic field. So one thing it was observed previously, like I discussed, is मान लो यहाँ पे कुछ field है, कोई magnetic field है ऐसे any direction, and there is a stable charge, there is a plus charge q here which is at rest. It is observed that this body will experience no force. Okay, magnetic field. This will not be only produced by charge. It will also be produced by current carrying wires which are neutral. So current moving charge and current will produce magnetic field. Along with magnets, of course, magnets के बारे में तुझे मतलब पता ही है. So these things will produce magnetic fields. Understood? Current carrying wires will produce magnetic field, moving charges will produce magnetic field, and magnets also will produce magnetic field. So when a charge is at rest in the presence of a magnetic field, when a charge is at rest in the presence of a magnetic field, it will experience no force. So this is very important point. In this field, when a charge is moving, then it will experience, when it's having some velocity in some particular direction, it will start experiencing deviations. So this is the projected path. This is a projected path. But actually what happens is that the charges will move a little, deviate a little to the right or deviate a little to the left based on their properties. Okay. So this charge which is moving, a moving charge will experience a force. Will experience a force. Now this force is caused, मान लो, if charge is producing this kind of magnetic field, even a charge at rest will experience opposite force. We know electrostatic forces. So this force is observed to not be electrostatic force. It is something else. This force is the force due to magnetic field. This is force due to magnetic field. समझ में आया? I hope it's clear to you guys. So one thing we understood right now is magnetic field will only affect moving charges. This will only affect, magnetic field will only affect moving charges. Affects moving charges only. So इससे हमें, I think one thing will be very clear to you guys now. So will it affect a current carrying wire? Magnetic field, will it affect a current carrying wire? Current carrying wire में क्या होता है? It is electrons moving. So yes guys, we will be discussing about that also today. Current carrying wire will produce magnetic field. A current carrying wire will get affected by a magnetic field. Clear? तो कैसा होगा? What will happen? All of them we will be discussing right now. All right. So the force on a moving charge due to a magnetic field is generally given by this. The force is given by Q into V cross B. तो इससे क्लियरली समझ में आ जाएगा ना कि this force will only act when velocity is there. This force will only act only when velocity is there. A charge at rest does not experience force due to magnetic field, but a charge which moves does, which is moving does. So the value of this is Q into V cross B. It has been experimentally found. Okay, the value of this is Q into V cross B. Q into V into B into sine phi, where phi is the angle between what are the two vectors here, V and B, velocity vector and B vector. Clear? So this is the main concept of it. When will force, a charge particle which is moving in a magnetic field will experience force. Okay. This is a very simple concept. ज़्यादा complex मत करो, ज़्यादा complicate मत करो, ज़्यादा मत सोचो. Eventually we will discuss about reference frames and all also while this is happening. All right, we will discuss about reference frames once we get clarity about how to apply this. Yo, so that's about it. So what will the force will be equal to Q into V into B into sine theta, sine phi या theta जो भी है. So best way of understanding it is, suppose there is a magnetic field in this direction and velocity in this direction. Velocity in this direction, magnetic field in this direction. Magnetic field को थोड़ा अंदर ले लेते हैं because it will be easier to solve. And magnetic field is like this, I mean say. So the direction will be given. मान लो a plus Q charge. A plus Q charge is moving in this particular direction. So you know how to find V cross B direction. I hope you guys know how to find V cross B direction. You put your hand in the direction of V first, then curl it along the direction of B. And one more thing you have to understand, it will be perpendicular to both. It is perpendicular. V cross B है मतलब it's a cross product, which means it will be perpendicular to the plane of both the magnetic field and velocity. All right. So I hope it's clear to you guys. Okay. तो अब direction के बारे में यहाँ पता चल जाएगा. Let's take direction of best है. यहाँ पे दिख गया. Direction of velocity is given like this. Wonderful explanation here, guys. If you definitely like this kind of diagrams and if you like to have this more representative kind of viewing, definitely share this video everywhere so that everyone can enjoy this kind of videos. So cross product cross V vector into B vector. ठीक है. The meaning is, तो पहले V direction, whatever the vector is first, you put your hand in that particular direction. तो मान लो यहाँ पे V vector ऐसा कुछ है. This is V vector. So first you put your hand in the direction of V. Is it clear? So first you put your hand in the direction of V and then you curl your hand towards the direction of field. तो मान लो यहाँ पे कुछ इस डायरेक्शन में फील्ड है, कोई इनवर्ट डायरेक्शन ले लेते हैं. A charge Q, V is in this direction and direction of field is inward. So what you do is you put your hand in this direction, whatever direction current is there, and then direct your fingers along the direction of the field. यहाँ पे Q जो है वहां से you swipe your hand, you swipe your hand from the direction of V to the direction of V. यहाँ पे starting V पे लगा दिए और direction of B यहाँ पे कैसे है, अंदर है. So what I'll do is I'll put my hand like this and put my I'll put my curl my hand in the direction of current. तो curl my hand in the direction of current से Q into V cross B अंदर है, तुम्हें बाहर दिखेगा बट मेरे लिए अंदर है. तो that is how it happens. तो एक बार ऐसे ट्राई करते हैं. Q ऐसे है. First put your hand in the direction of V and then curl your hand in the direction of B, which is inward. तेरे लिए तुम्हारे लिए inward है. ये इसको थोड़ा मतलब it's always tough to do right hand when you're facing the camera and doing it. Okay, I already had this issue once. फिर से हो रहा है. तो इसको invert करना पड़ेगा. But then if you invert, the entire Unacademy brand will become immediate. So let's use your own intuition. अपने hand से use करो. पहले hand V के direction में लगाओ. उसके बाद curl cross means it is going inside. It is going into the plane of the page. तो यहाँ से यहाँ तक इस डायरेक्शन में अपना हैंड को when you curl, what is the direction of thumb? The thumb is always showing this way. If you observe, the thumb will always show this way, which means this is the direction of force on Q. और सिंपल डिस्क्रिप्शन है यहाँ पे. कटिंग इज गुड. थैंक यू रा. थैंक यू. अरे so sorry guys, I've been trying to have this integer quiz show, the second episode, but it's not been happening. Today we have it. Yesterday there was some current emergency, there was no power at home, so we had to make do with some other stuff. But today we will definitely have the quiz show, integer quiz show number 2. I have everything planned for this. So definitely come there Ramesh, and definitely stay tuned to this class. So example best यहाँ पे देख लो. The best way, that's why I put this diagram so that I will not confuse you with my thumbs and fingers, because it's all inverted right now. For me left is right, right is left. For you it's ulta. So the direction of Q, so imagine it this way. You curl your hand inwards into the screen you're watching. What is the direction of thumb? You will see thumb will be pointing in the downward direction like this. So this is how you find force. There is another simpler method which is which is called as the palm method. इसको मैं बता दूंगा, ठीक है. तो इसमें क्या है कि yes, there is another nice simple method which I'm going to tell you right now. It is called just give me one moment. So यहाँ पे देख लो. So you curl your hand to get the direction of V cross B, which is directly pointing out upwards in this particular diagram. So इसको, this is the direct direction of force. And if the force on a negative charge particle, the force on a negative charge particle will be minus Q, where Q is the magnitude, minus Q into V cross B, which means the direction will become reverse of this. The direction will get inverted. When you remember this now, when you multiply any vector with a negative number, negative scalar quantity, the direction will reverse. That is what will happen here. And the direction of force on negative charge, negative force on negative charge will be opposite of force on positive charge. तो ये हमेशा तुम लोगों को ऑलरेडी पता होगा, but then this is the standard procedure. Now I'll tell you one more nice method where suppose you put your thumb in the direction of velocity. Put your thumb in the direction of velocity and put your pointing finger मतलब ये pointing finger, these are the two fingers you will see. Just मतलब palm को use करोगे ना तो ऐसे देखोगे, there are only two things. One is thumb, one is this thing. Pointing finger in the direction of P, and then whichever direction your palm moves, palm direction is direction of force. Is it clear? तो मतलब simple सा उसी example को देख. You put your hand in the direction, or like in this particular direction, you put your hand in the thumb in the direction of velocity, and finger in the direction of the field. So the palm or this middle finger, this is called as the Fleming's right hand rule. Either the thumb, either the pointing finger, palm, or pointing finger will give you the direction of force. Clear? तो इसके बारे में we'll discuss more about it as we go further. We will definitely have a nice depiction of this in the coming class, because I already had one of this discussion there. So stay tuned to that. Okay, so the force acting on a charged particle moving with velocity v through the magnetic field is always perpendicular to velocity and p vector. Like we know force is q into v cross b. तो वही है, तो ये हमेशा ऐसा ही रहेगा. Like example of this taken from a laboratory photo, an electron, it's a positron. This is called as a positron. A positron deflects in one particular direction and the electron deflects exactly in the opposite direction. Okay, so this is one more explanation of it. So this is a simple question, guys. I want you guys to figure out how the direction of force on each particle will be. Okay, so जो कर रहे हैं वो कर लो. I want all of you guys to start solving this problem right away, and if you have any answer you can just put it in the comment section. All right, feel free, but I'll keep solving slowly. Let's see how many of you can do faster. I want to see how many of you can do faster than me. The human calculator. All right, ठीक है, छोड़ो. So velocity direction is first. Direction of B is downward. So the direction of, in the first case, in case A, direction of V is in the minus I cap direction. Velocity is in the minus I cap direction, and B is in the minus J cap direction. So इसको मैं mathematically भी कर दूंगा और I'll show it using the right hand rule also. पहले thumb is showing velocity, field is showing this way, and the direction of the right hand middle finger will be the direction of field. Or you can also say direction of whichever direction your palm is facing is the direction of force. Velocity इधर है, field downwards है, the force will be coming outward. It will be coming out of the screen. So wo logically we can say it is coming out of the screen. Out of screen implies it is plus k cap. Okay, तो इसको वेक्टर फॉर्म में भी लिख सकते हैं. It will be how much? Since it's a positive charge, we will directly say q into v cross b, which means q into v is minus I cap cross minus j cap. What is minus I cap cross minus j cap? Minus I cap dot minus j cap कितना है? It is plus k cap. Take minus and minus common, दोनों plus हो जाएंगे, and you know the standard rule, right? I, j and k. For cross product, this will be used. I cross j will be k, j cross k will be I, and k cross I will be equal to j. Anything reverse of this is clockwise. Anything reverse of this, it will become minus. The I cross j will be k, j cross k will be k, I, and k cross I will be j. And what will be equal ulta of is I cross k will be minus j. समझ में आ रहा है ना? I hope you understood this logic. Hello Sairam Garu, good evening Amma. I got a new haircut today, finally. So QVB into I cross j will be given by how much I cross j will be direction will be equal to, which is exactly what we derived using the palm rule. All right. So similarly, अब यहाँ पे v direction नीचे है और v direction अंदर है, तो direction of force will naturally be in this direction. सही है? Clear? नहीं, it is wrong. Why? Because the charge here is taken as negative. The charge here is negative, which implies the direction of force will just pultify and it will become minus I cap direction. So this is the method. So we will solve this using v cross b also. Velocity is in which direction? Velocity is in minus j cap direction, and field is in minus k cap direction. So what is the direction of v cross b's direction? V cross b will be minus j cap dot minus cross minus k cap. Minus minus को निकाल दो, तो j cross k will come out to be I cap, and the force will be in minus I cap direction because charge is negative. Clear? For B, this is the answer. समझ में आ गया? Guys, if you like this, definitely don't forget to hit the like button, everyone. Don't forget to hit the like button and share this video everywhere. Alright, तो यहाँ पे फिर से लिख दूंगा वो I, J, K. So this is the method. I vector cross J is K, J cross K is I, K cross I is J. Now for the third one, just by using the logic, we will using the right hand thumb rule, rule, we will say direction of velocity is downward, direction of field is upward. What is the angle between both of these? The angle between both of these is 180 degrees. You can also send both of them are along same direction. V vector is along minus j cap and B vector is along plus j cap. So what is the direction of V cross B? Anything which is both j caps means the direction of field will be 0 or the force will also be 0. So this is it, guys. I hope you understood all the individual explanations of it. Of directions के बारे में, I hope you are pretty clear. So now a little inference about what we studied till now. One thing we know, force is always perpendicular to B vector, right? The force is always perpendicular to V vector and B vector because it's a cross product of both of them. A charged particle at rest in a steady magnet does not experience any force. If the charged particle is at rest, then V will be 0, so V cross B will also be 0. एकदम simple सी explanation है. Moving charged particle does not experience any force in a magnetic field if its motion is parallel to the or anti-parallel to the field. This one we just figured out right now. If angle between V and B is 0 or 180, what is the value of sin theta? It will be 0. So QVB sin theta, बस यही याद रख लो, force will be equal to QVB sin theta. Any one of these is 0, then the answer is 0. The field is 0, the answer is 0. There will be 0. एक बार देखते हैं. When charge is 0, a neutral body will not experience a force in a magnetic field. Velocity is 0. A charge at rest will not experience any force in a magnetic field. A neutral body will not experience any body. Charge. Neutral body नहीं, any neutral charge. Neutral charge क्या बोलते हैं? And one more thing is when the field is 0, when there is no field, obviously no force. में कुछ बताने के लिए है भी नहीं. And the last thing is when sin theta, the angle between velocity vector and B vector. So both are non-zero. The angle between them, if it is equal to 0 degrees or 180 degrees, then the field will be equal to. It should either be parallel or okay. So this is about it, guys. So logically, we can just derive this equation saying maximum force when velocity is perpendicular to the magnetic field. When force is perpendicular to the magnetic field, तब क्या होगा? So maximum velocity will be maximum force when velocity is perpendicular to the magnetic field. Oh yeah, this is what we discussed. This is a very nice indication of the force. Force will be equal to QVP sin theta. When theta is 0 and 180 degrees, the force is 0. As shown here, this middle one gives the direction amount of force. So when it becomes perpendicular, the force is maximum. When this becomes perpendicular like this, the force will be maximum. Alright. So force due to a wire on a moving charge. Let's take a simple example of this. एक simple सा छोटा सा example लेते हैं. There is a current carrying wire having current is equal to, let's say, some 2 amperes. Alright. 2 amperes current is flowing in a wire, and at a point at a particular distance का value कुछ 5 meters ले लेते हैं. At a distance of 5 meters, there is a charge plus Q is equal to some 20 microcoulomb. A charge of 20 microcoulomb is placed at a distance of 5 meters from a infinite current carrying wire. Infinite current carrying wire के बारे में field कितना होगा? We discussed this already. भूलो मत. We will use this. Find the force due to a wire on a moving charge. इसका velocity दे देते हैं कुछ downward direction. We'll say the velocity of this is some 4 meters per second. What is the force on this moving charge? From this you'll understand just how small the force due to a wire will be on a moving charge. ठीक है. First of all, what is the value of field here? Field produced will be equal to mu naught I by 2 pi r due to infinite charge. Infinite charge का बारे में याद है ना? Infinite wire will produce this field. Infinite loop will produce pi times this. Remember, we also discussed pi is to 1 is the ratio, right? So we will do that only now. Infinite charge, इसका लॉजिक क्या है? लास्ट पॉइंट का लॉजिक कौन सा? लास्ट पॉइंट का यही तो है जो when the angle is 90 degrees, no, when the angle is 0 or 180 degrees, the value of sin theta, what is sin 0, will be equal to sin 180 is equal to 0. QVB sin theta जो है, QVB into sin phi जो है, if this is 0, the whole force will be 0. Clear? I hope that's the doubt you had. तो अभी इस क्वेश्चन का आंसर सॉल्व करते हैं. If you guys do it fast, please put it in the comment section below. I will solve it slowly. Let's see how many of you can do faster than me. Alright. B का वैल्यू है mu naught I by 2 pi r, which is, तो इसका पहले हम एक और we'll also write it in this way, mu naught by 4 pi into 2 I by r. क्योंकि इसका वैल्यू जो है हम बहुत अच्छी तरह से याद रख लिए. इट्स द वैल्यू ऑफ दिस इज 10 power minus 7 and then we substitute the value. B will be equal to 10 power minus 7 into 2 times I, which is 2 into 2 by separation, which is 5. So इससे what is the value we are getting? 0.84 by 5 into 10 to the power minus 7 Tesla. Now what is the force on the field will be Q into V cross B, or we can also write it as QVB into sin theta. Theta is the angle between sin phi जो भी है. Phi is the angle between velocity vector and the field vector. तो पहले हमें फील्ड का डायरेक्शन, फील्ड का वैल्यू हो गया. अब डायरेक्शन, रिमेंबर यू हैव टू यूज द कॉन्सेप्ट ऑफ थंब एंड कर्ल मेथड. तो इससे सीधा हमें डायरेक्शन ऑफ दिस विल कम आउट टू बी इनवर्ट्स. पुट योर थंब इन द डायरेक्शन ऑफ put your thumb in the direction of current and whatever in the right hand, and the direction of your curl will give you direction of field. तो इसमें I'm putting my hand and R vector is somewhere here. तो ये direction में अगर curl करूँगा तो direction of field is coming inwards, right? So this is the direction of field is inwards. And now we will use the same concept. We'll use your thumb in the downward direction and force. The direction of force will be कैसा होगा? कौन सा डायरेक्शन में होगा? डायरेक्शन ऑफ फोर्स will be along the I cap direction. It will be along I cap direction. Given I cap is this way, J cap is this way, and K cap is this way. All right. So this is the three directions. So to इसमें direction will be direction will be along the V cross B, be along I cap direction. अब एकदम हमें same we'll use a standard rule of hand. एकदम यहाँ पे force velocity is downwards and field is inward. So direction of thumb, direction of the third finger or the direction of the palm is pushing it this way. So if it is pushing, okay, उल्टा है, मतलब तुम्हारा direction में उल्टा होगा. Explain this. ठीक है. Direction of velocity is downwards, direction of field is inwards. तो एकदम दोनों को करेंगे तो direction will be in this direction. Alright, sorry, don't mind the previous one. Direction will be in this direction. तो इसका direction along I cap direction हो जाएगा. I hope it's clear to you guys. It will be along the I cap direction. So the force will be QVB sin phi in the I cap direction, which is equal to, what is the charge? 20 microcoulomb, which is 20 into 10 to the power minus 6 into velocity is 4 into the field is 0.8 into 10 to the power minus 7 newtons. And into sine of the angle between them. What is the angle between these both? By logic we can know both of them have an angle of 90 degrees. So this is coming out to be 64 into 10 to the power minus 13, or 6.4 into 10 to the power minus 12. So the value of force is actually very less. Okay, the value of force is actually very minimal due to a force due to a wire on a moving charge. Force due to a wire on a wire. I will not be solving this problem, but I will be explaining the logic of this. Okay, we will discuss about this later. But when suppose there is a current flowing, the current is flowing in this particular direction, and there is also another wire where current is flowing in this particular direction. So what will happen to the force acting on the wire? What is the direction of force acting on the wire? Okay. So इसमें one thing you know, the direction of current, the direction of electrons will be downwards. Electrons will have this direction velocity, right? And here directly I will use Q into V cross B. I will use force on electrons will be Q into V cross B. Minus E, V cross B. So if you take it, it can also be written as I into V cross B, direction of current into velocity. Direction of current is nothing but the opposite of direction of velocity, right? Direction of current is opposite to direction of electron. Anti-parallel है ना ये. This is anti-parallel to the direction of electron. So directly I can say I into V cross B I can write off. I into V is the V of electron. In this way I can solve. So there is a lot of electrons flowing this way. So the total force will be based on this. So we can directly take the direction of velocity to be direction of current. सो इससे सिंपल सा लॉजिक क्या बता दूंगा, टेक डायरेक्शन ऑफ वेलोसिटी to be equal to direction of current, current element, current element जो हम डिस्कस किए उसी डायरेक्शन में we can use this. Okay, the direction of velocity will be along this direction and we know the field, so the direction of velocity I will directly take it this way. क्या लूंगा, so I'll take the direction of velocity to be this way of charge, velocity of charge to be this way, and the direction due to this will be inwards as we discussed. Direction of field will be inwards. So using the same logic, इसको अंदर डाल दिए तो the direction of force will be in the opposite direction, given to V cross B. So the direction of force कितना होगा, towards the direction of, so इन दोनों के कारण क्या है, velocity is in the upward direction, V is in the downward direction. Using the right hand rule, we'll get the direction of force will be this. So from this what can we say, same direction wires, so मतलब direction of force will be attractive. Using these both, V cross B will be in this direction, so we can say it is towards the other wire. I hope it's clear to you. The direction of force will be towards the direction of other wire, which means the current carrying wire will attracts another wire in same direction. Another wire in same direction of current. Okay, so both of them, this body will attract this body towards it. So from this we can say same direction current is attraction, and opposite direction will be repulsion. I hope it's clear to you guys. Awesome. So a vector example, एक छोटा सा vector example दे देता हूँ so that we can solve vectors also. Find force on a charge, on a 10 microcoulomb charge moving with velocity is equal to some 4 I cap plus 6 j cap, and in a field B given by some 10 I cap minus 4 j cap. Alright, तो इसमें हम कैसे सॉल्व करेंगे, हाउ डू, सो k cap भी लिख देते हैं, प्लस 3 k cap लिख दो, यहाँ पे कुछ प्लस 2 k cap लिख दो. तो व्हाट इज द वैल्यू, हाउ डू यू फाइंड दिस? तो इसका सोल्यूशन एकदम सिंपल, मैथमेटिकली विल सॉल्व इट मैथमेटिकली so that everyone understands how to do cross product also. Mathematically, force will be equal to Q into V vector cross B vector. V vector cross B vector, how do you find it? So इसके लिए you know the standard technique, right? Determinant method. You will use the concept of determinant method. This is very useful, guys. Determinant method, you have to understand how to solve this, because mathematics में lot of this will happen. Mathematics में lot of this cross product will happen, and you have to be able to solve it in determinant method. Determinant method में क्या है, यहाँ पे I ले लो, यहाँ पे J ले लो, यहाँ पे K ले लो, and you write V cross B. No, you're doing V cross B, so write V first. 4, 6 and 3, and write this next. So इसमें हमेशा we can, the concept is the V cross B will be equal to, ये जो I जो है ना, just close the I just for one moment, just make this invisible, make the I को एकदम block कर दो, log this I, and whatever remaining is there, you just find the determinant of these both. I hope I am clear to it. तो इसके बारे में कैसे लिख सकते हो, it will be equal to I into 6 into 2 or 6 into 2 minus 3 into minus 4, and इसके लिए minus लिखना है, this is very important. So you write minus j cap into, again now you block this and you cross multiply the other. 4 into 2 हो गया, minus 3 into 10. So you sub determinants है. Find out basic determinant of everything. Plus k cap direction में you close this one end and start multiplying the other two. 4 into minus 4 minus 6 into 10. So what is the entire value given by? I cap into 12 minus minus 12, which is 24, plus minus j cap into 8 minus 30 is minus 22, plus k cap into minus 16 minus 60 is minus 76. So from this, what do we get? The value of v cross b is given by 24 I cap minus 22 j plus 22 j cap minus minus plus हो गया minus 76 k. What is the force now? Charge into this, which is nothing but 10 power minus 5 into 24 I cap 22 j cap minus 76. So this is how we calculate the force acting on a moving charge. I hope you will like this, guys. Alright, now moving on to another example. Which of the following options is the acceleration of a body which moves with a velocity of 4 I cap plus 8 j cap in the presence of a uniform magnetic field? अब ये एक अच्छा trick question है. The concept is you know the velocity vector but you don't know where the magnetic field is at. Without magnetic field, how do you solve this problem? This is what I want you guys to analyze. Okay, the force is given by q into v cross b. So one thing we know, that force is perpendicular to v vector and force is perpendicular to v vector as well as v vector. Now the velocity vector is given by 4 I cap plus 8 j cap, and so this thing you have to also understand, the force dot v vector will be equal to how much? Fv cos theta, which is f into v into cos 90, which is equal to 0. So the dot product between force and velocity and f dot b will always be equal to 0. If you divide by mass here, what will we get? Acceleration dot v vector will be equal to acceleration dot b vector will be equal to 0. So we find out dot product of which of the options will have 0. So 2 I cap plus j cap dot 4 I cap plus 8 j cap नहीं आएगा, because everything is plus 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 plus. 2 I cap minus j cap, तो add करो 2 into 4 minus 8 into 1, which is equal to 0. So the answer is B. अब कोई ना कोई problem नहीं है, we can have multiple choice also. So let's see the other two. This is I cap plus 2 j cap, so everything is plus here and here, so it won't work. 4 I cap minus 8 j cap, 4 I cap plus 8 j cap. You observe both of them. 4 into 4 minus 8 into 8 is equal to minus 48, which is not equal to 0. Hence, this is also not the acceleration direction. Clear? Acceleration direction is always along the direction of force, and whichever direction force is there, and force is perpendicular to both velocity and magnetic field. So यहाँ पे which of the options which is perpendicular to the direction of velocity, that is the answer. Alright, awesome guys, awesome sauce. So one more thing we have to, very important point you have to understand, this is a key. This is key for your understanding of this topic, which is work done by the magnetic field. So what is the work done by a magnetic force? Force due to magnetism. One thing we know, force is Q into V cross B, and V is ds vector by dt vector. And so what will we get? Force vector can be written as Q into ds vector cross B vector by dt. ऐसे लिख सकते हो. And what is F dot ds? So one thing we know, very important point about cross product and dot product, when force is perpendicular, so from here you can also say force is perpendicular to displacement vector, right? इससे क्या आएगा? Force is perpendicular to displacement vector, so F dot ds will be equal to F into ds into cos of 90 degrees, which is also mentioned here. तो इससे हमें क्या समझ में आएगा? Force is perpendicular to ds, so the angle is 90 and cos 90 is 0, so value of this will be equal to 0. So one thing we know, work done by magnetic field will always be equal to always 0. Okay, this is one very important concept. So you can start applying work energy theorem also. You can start applying work energy theorem of different types can be applied, where initial potential energy and final initial potential energy and kinetic energy will be equal to final potential energy and kinetic energy. Many such things can be done using this. All right. So as by work energy theorem, work has change in kinetic energy. So half mv square remains unchanged, which means that the speed of the particle which is inside a magnetic field, speed of a particle which is inside a magnetic field under the influence of only magnetic force, magnetic field, will remain constant. तो मतलब अब यहाँ से तो क्लियरली समझ में आ गया होगा, when the speed is constant but that force is always there, what kind of force is that? So force is mass into acceleration, right? Acceleration can be written as acceleration centripetal plus acceleration radial. You can also write it in different ways like this. So we know for one thing for sure, if the force is always present but speed is not changing, it means force is only changing direction. Is only changing direction. I hope it's clear. Magnetic force only causes change in direction. This is a very important, awesome point. Magnetic field will only cause change in direction. Will not cause change in speed, only change in direction. So, what kind of forces will only cause change in direction but not change in speed? This is very similar to circular motion, centripetal force. तो वही होगा, exactly वही है. This is exactly what magnetic field does. It produces centripetal force. A magnetic field will produce centripetal force. I hope you understood this now. Any force which is only causing change in direction but no change in speed will always be perpendicular to the velocity direction, and it will be centripetal in nature. And centripetal force, so magnetic field also produces centripetal force. All right. So that is about. Before we move further into this, I want you guys to understand little about Unacademy platform. Crack IIT-JEE with India's largest platform, which is Unacademy right now on online platforms. So it's a learning online platform. Get the plus subscription using the code NSS1 to get the best courses from India's best educators. What do you get with plus subscription? You get access to the best of Unacademy. So what is that? Let's see a little into it. It has daily live classes. It has daily live classes where you can chat with your educator, engage in discussions, and ask your doubts, answers all while the class is going on. Everything. So here there is a little delay like we just saw. So when to expect JEE 2021? It will mostly be January में ही होगा. There won't be much change in the JEE syllabus. Just rock it. Okay, just rock it. Yeah, यहाँ पे like you can see the delay is there between the discussion and the feedback. But यहाँ पे everything happens dynamically. The moment you can send your photos, you can send photo doubts, you can send everything. The moment you send those, it will be visible to the educator who will help you with your doubts and also discuss it with you, along with putting a lot of awesome and insanely cool polls. Polls are for quizzes, just like the integer quiz show which is going to happen today at 10:30 p.m. Stay tuned in. Search for the name N Srikant and you can subscribe to me, and then you can get to the integer quiz show. Alright, so not only that, you also get live tests and quizzes where you can evaluate your performance with regular mock tests. As I keep telling, a quiz a day will keep you ready for JEE any day. You have to prepare with quizzes and tests every day, which will be given to you in the plus subscription. And all the courses are in structured manner. Like even if you miss a class outside, you can listen to the classes here. And this is also the advantage from outside, where once you miss a class, it will be very tough for you to get follow up to it again. But in this particular case, you have structured course. Everything is given in line, step by step, so that you can optimize your preparation strategies. And you will also get unlimited access to all the teachers' content from across the country, not just one or two teachers, but all the teachers from across the country. Cost of this is 38,500 for 1 year. 38,500 for 1 year. And using this code NSS1, which is like a bonus discount for you guys, it comes out to 34,650 for 1 year. Similarly, 6 months is 28K. It comes out to 25.2K for 6 months. All right. So those guys who want to really crack IIT-JEE with a lot of intensity, you can definitely go for this using the code NSS1. And this is for the the long game guys who are going to crack JEE in 2022. You have 2 years left. The cost, you have to take the 2 year subscription. The cost of this is 56,000. Cost of the 2 year subscription is 56,000. Not only that, you use this code NSS1 code 1 to get it for 50,400, which is pretty cool. These numbers might seem big, okay, but let me tell you what Joker said: when you're good at something, never do it for free. So this is the nominal charge Unacademy is giving you. This might sound big in the beginning, but let me break it down for you. This comes out to 2,887 rupees per day, per month. After using the code NSS1, this comes out to 96 rupees per day, or you can also say 32 rupees for physics, chemistry, and maths. Matlab, instead of buying a chocolate, you can just use this code and you and take a full subscription. Alright, similarly, this now the 2 year course will come to you for 23 rupees per. So if you see it in the short term, and those who prepare for JEE should prepare consistently every day. So this is the amount of cost it will happen for 2 years. Alright, not only this, Unacademy has also launched the Iconic subscription where you'll take your IIT-JEE preparation to the next level using a personal coach. This is for all those students who have trouble who have trouble right now, especially in these hard times where you depend too much on the teacher to get a strategy, and now the teachers are not there with you to help you with your strategies. So Unacademy is giving you a personal coach for exactly that. You will be given a personal coach just so that you can prepare. So you will be given a personal coach who will help you with aligning your course preparation with your preparation strategy. He will analyze you about what subject you're doing well, which part you're doing well. Everything will be given to you, along with a detailed test analysis where every question, how much time is taken, what is the average time, all of those information will be given to you, as well as your personal coach who will analyze your tests and devise a detailed study planner, weekly or bi-weekly or anything based on your comfort will be given to you guys. So this all in a very educationally positive loop. This will help you. This will be a positive loop, and it will help you with developing your performance. All right. Not only this, you will also all the benefits of Plus will also be given to you guys. Now the cost of this, if you look into it, is 56,000 for 1 year. Use the code NSS1 to get it for 50,000. This comes out to 46 rupees per day. With a mentor, it's pretty cool again. And those who want to take till 2022, and those who believe the vaccine is not coming till 2022, take this 2 year course using the code NSS1 to get it for 77,400. This comes out to 32 rupees per day for physics, chemistry, and maths with a mentor. मतलब यार इतना मस्त डील तो कहीं नहीं मिलेगा, so definitely go for it. All right, so motion of a particle in a magnetic field. Now we realize how the particle will move. We know work done is zero. We also realize that the force is always perpendicular. Force is perpendicular to velocity, and we also know work done by force is zero, which implies the kinetic energy will remain same. So a particle which is having same speed, which means speed will remain same. So we know speed is same when force is perpendicular to v vector. Where the speed will be same and the direction of and force is always present, which implies the direction of motion will be circular. Alright. So इसमें पहले motion of charged particle in a magnetic field. So we'll discuss about different cases when it is moving collinear with the field. When it is moving collinear with the field, in this particular case, when both of them are along same line or opposite lines, it means they are either parallel or anti-parallel. So in this particular case, the force will directly be equal to zero. When the force is zero, what will happen to the charge motion of the charged particle? It will start moving with inertia, which means it will move with constant velocity कांस्टेंट वेलोसिटी, इसका मतलब क्या है? इसका मतलब फोर्स जीरो है। फोर्स जीरो है मतलब वेलोसिटी विल रिमेन स्टेट। ऑलराइट, सो नाउ सो इसका और डिटेल्ड वर्जन मैं बता दूंगा। सो व्हाट कैन वी से? फोर्स विल बी गिवन बाय q into v क्रॉस v, राइट? So when v is fixed, we can also write it as q into v vector, uh, v times q into v into b times v vector cross v cap cross, ऐसे भी लिख सकते हैं। So one thing you have to understand, force is dp by m into dv by dt we will take because the mass is not changing, and this velocity vector I'll write it as v times v cap. So if I write this like this, what will I get? Mass into dv by dt times v cap plus m into v into dv cap by dt. So this is how we solve it. So this is along the direction of along speed, along velocity, because the direction is ma into v cap. So this is coming out to how much? M into a v cap plus m into v into dv cap by dt. So this is along v cap direction, and this is perpendicular to v cap. So I hope it's clear to you guys. Now, motion of a charged particle in magnetic field. When a charged particle is moving perpendicular to the field, when both of them are perpendicular to each other, the force will be equal to q will be always perpendicular to the motion, and the charged particle will be moving in a circular path with its plane perpendicular to the field. मतलब मान लो कुछ velocity, कुछ magnetic field अंदर ऐसा है, and a charged particle is moving, some plus charge only will take, which is moving with velocity like this direction. तो एकदम इससे हिसाब से हमें क्या आएगा डायरेक्शन ऑफ इट? E cross B, E cross B. Direction of this charged particle will be upwards. तो यहाँ पे ऐसे करके, and there is a charged particle here moving with velocity. So V cross B, the direction of force on this particular case will be upward direction. The direction of force will be upwards. And after some point it reaches here with a velocity v like this. Let's take after some point it is moving, because the force is pushing it up and up, at some particular point it will move like this, and at this point the force will be inwards. So if you observe carefully, the entire body, if the positive charge is there and the particle is moving with velocity v, it will be constant force inwards, as a result of which the trajectory of the particle will be like this. This is the trajectory of charge in a field. And what is this kind of motion? It is circular motion. So I hope you like this, guys. Okay, so this is the best representation of it, is represented by the cross lines into the page, and for there's a charged particle of having charge plus q here, it is moving with velocity v inside, and the forces are, as a result of which v cross b will be inwards. Agar same situation mein, if I take a negative charge, what will happen? The velocity will be in outwards, so q v cross b into minus q, as a result of which the direction of circle will be down. A negative charge will make a circle like this, and a positive charge will make a circle. This plus q charge motion, this is minus q charge motion. So this is a small test question for you guys. Come on, solve it. Think about this. A neutron, a proton, and an electron and an alpha particle are enter a region in a constant magnetic field with equal speeds. मतलब equal speed से everything is moving together. The magnetic field is along the invert normal to the plane of the paper. Tracks of the particles are shown in the figure. Relate the tracks to the particle. Relate the tracks to the particle. तो अब एक्सेलरेशन कितना हुआ? ओके, तो इसके बारे में, तो रेडियस के बारे में एक बार, so we will track the, so before we go further, just give me one moment. We will also understand the time period and how it's moving in circle. We understood one thing, it is moving in circular motion. अब इसमें क्या क्या होगा, मतलब सर्कुलर मोशन में काफी रहेंगे ना. सो लेट्स गो टू दैट पार्ट फर्स्ट बिफोर वी गो टू द नेक्स्ट क्वेश्चन. एक बार सर्कुलर मोशन में क्या हो रहा है विल फिगर आउट. So one thing we know, Force centripetal will always be given by what? mv square by r, right? We already know this. And from this particular example, we also got force will be equal to q into vb sine theta, or I'll write in this particular special cases like full circle cases, it will be qvb. So we can simply equate both of them. mv square by r will be equal to qvb. From this, what do we get? mv. So from this directly we can just cancel out one of those v's. We will directly get mv by r is equal to qb, or we can also say radius will be equal to mv by qb. So this is a wonderful definition, guys. The radius will be given by mv by qb. So I hope this is clear to everyone. When a particle is moving in a uniform magnetic field, the radius of the circle it subtends is mv by q. So this is the radius of the particle. Now, अब radius है constant, velocity है. Velocity is constant. Radius is also given. Speed is constant. Radius is also given. What is the time period? Time period will be equal to the total circumference by velocity, right? We will substitute this, which is 2 pi mv by qb divided by v. So it's a v cancel हो गया. And one very interesting observation, guys, the time period of motion in the circle is equal to 2 pi m by qb. This is independent, if you observe, this is independent of, the time period is independent of the speed of the particle. So I hope you understood this, guys. The time period of making full circle is independent of the speed of particle. The radius, on the other hand, is proportional to it. Radius will be proportional to velocity, radius will be proportional to mass, and radius will be proportional to 1 by charge. So these kind of things I want you guys to understand, because most of questions will be, if you think about them in ratios, it will be very easy to solve. So velocity is increasing, close your eyes and imagine. Velocity of the particle is increasing, it will make bigger circles because radius will increase. Mass is more, it will be tough to pull it inside, no? So it will make bigger circles. And charge is more, the effect of force will be more, it will make smaller circles. So radius will be proportional to v power 1. R is proportional to v power 1, m power 1, q power minus 1. So this is how it goes, guys. The radius will be proportional to v, mass, and inversely proportional to charge. And the time period, on the other hand, time period is independent of velocity. Very nice observation. And then time will be proportional to mass, logically, because mass is more, it will react slowly everywhere, and it will be inversely proportional to charge also. So I hope you understood this. Now you can solve this problem. Now let's see. A neutron, proton, an electron, and an alpha particle enter a region of constant magnetic field with equal velocities. All of them have same velocities. The magnetic field is along the inward normal to the plane of the paper. The tracks of the particles are shown. Relate the tracks to the particles. One thing we know, when neutral particles will not get affected. So this C here is a neutral particle. What is neutron? The neutral particle is neutron. From this we can say neutron will be equal to C. एक बात तो clear हो गया. Now only one of this. So alpha particle is what? Alpha particle is 2He. He2 plus, right? So alpha particle is He, helium 2 plus. So it has more charge than a proton for sure. Helium has charge of plus 2E. And proton has plus C, electron has C. Getting it? Where E is the standard unit of charge, which is 1.6 into 10 to the power minus 7. 10 power minus 19 coulombs. Alright. So we know one more thing. One more thing we know from this is that radius will be proportional to 1 by charge. Radius will be proportional to 1 by charge. It is also proportional to mass. If you observe, it is proportional to mass and it is proportional to 1 by charge. So radius will be 2 pi m by qb. No, it is given by 2 pi m by qb. This is pi m by. So it should be proportional to m by b ratio. If m by b is more, then the radius will be more. If m by b is less, the radius will be less. So if you observe carefully, for electron, it will be mass of electron by b. For proton, it will be mass of proton by charge. M by 1 electron, 1 E, mass of proton by E. And what about the helium? What about the alpha particle? Alpha particle will have 4 times mass of proton, right? By 2 times the charge of electron. So from this we can say the radius of alpha particle is greater than radius of proton will be greater than radius of electron. And we also know electron will deflect in the opposite direction because it has negative charge. So एक बात तो clear हो गया, this will be electron for sure. So electron is D for sure because it is the only particle which is reacting in the other direction. Now A and B, one of them will be alpha particle, one of them will be beta, one of them will be proton. From this we already discovered that R of alpha will be greater than R of proton. So which of these both has greater R? From clearly we can say B has greater R. So B will be an alpha particle and this will be a proton. I hope it's clear to you guys now. So alpha particle will have more mass for mass by charge ratio. It will all depend on mass per unit charge. Mass per unit charge. Okay, more mass for a given charge, it will have bigger radius. All right. So a helium has 4 atomic mass and 2 plus 2 charge. So the mass per unit charge is 2 units. But for proton it is 1 unit and for electron it is much less. So the radius of electron will be much smaller than the radius of other materials. So that's it guys. I hope you understood this. So the charged particle is moving at a theta. What happens? What happens when the charged particle is moving at a theta with the field? So this is very important concept. Hamesha, whenever you have this kind of vectors, this kind of angles and all, simple, divide them into vectors. So resolve your vector into v vector v1 along line of field and v2 perpendicular to field. This way you can solve every problem because along the field we know already that there is no impact. So along the field jo hoga usme even now there won't be any impact, but perpendicular to the field what will happen? It will move in spiral, move in circle. So one component will move in circle, the other component is moving with constant velocity. In this kind of cases, what is the kind of image which forms? The image which forms is a helical path. Great explanation here, great description also here. The image formed will be a helical path. Helical path matlab jaise ki in this particular diagram. In this particular diagram, the direction of field is along the x direction. The direction of field is along x direction and the velocity is having angle theta with the horizontal. So v cos theta is the component in the along the direction of v cos theta is along b vector and v sin theta is perpendicular to b vector. So this will cause circular motion and this will cause linear motion. So both of them together will form a kind of a spiral, which you already know this is spiral. So result of both of them will make a spiral path, which is also called as helix or helical path or helical. So इसमें कितना दूर? So all these things we will analyze more about this helical path now. So oops, ये पहले आ गया. So we will analyze the helical path now. So one thing we know, the radius of the helix will be only caused by vertical component, right? So it will be equal to mv by qb, mv perpendicular by qb. What is the value of this? It will be equal to mv sin theta by is equal to the radius of the. So now one more thing, for helix you have to not only define radius, you also have to define the distance between two loops. That is only called as pitch. Pitch is the separation between two loops. Pitch is separation between two loops. एक loop ऐसे start होगा, दूसरा loop will, if you see a spring, best way to understand is a spring. Or even this here, this particular small example I am going to show you. So if you see, this is the helix. Right. So yeah, this starting point से यहाँ starting point है. From here till this, from this point to this point, there is a difference, but it's coming after making a full circle. So this perpendicular distance between this point and this point. यहाँ से it is making one full circle and then coming back to the same level, which means this component will only be caused due to this component is caused by horizontal component V along B. This component will be caused by V along B. So what will the separation be? Separation will be equal to time period into velocity along B, which is also equal to V cos theta. So this is what we can write, time period. This will be equal to time period into V into cos theta. This is the pitch of a helix. TV cos theta, cos theta. So what is the value of time period here? We also found out this value. Time period will be equal to 2 pi m by qb. This is independent of the velocity. It is only proportional to the magnetic field and charge and mass. So if we substitute this here, we will get 2 pi m by qb into v cos theta is only equal to the length of the pitch. I hope it's clear to you guys. So आराम से the time period is given by 2 pi m by qb and velocity along the direction is v cos theta. Multiply both of them, you're going to get this one wonderful complex equation, which is exactly what is given here. 2 pi m by qb into v cos theta. All right. So this is about magnetic field, guys. I hope you understood this. We will come up with much more concepts tomorrow. All right. So that's all for today. Adios, amigos. Don't forget to hit the subscribe button and share this video everywhere. This is Let's Crack JEE in English for you guys who want to understand only in English. Use the code NSS1 when you're taking the plus subscription. Hit the bell icon and like this video. All right. So we will have loads of problems and much more analysis about current moving in charge tomorrow in our next section. Until then, see you guys. Tata. Adios, amigos.